All right, welcome everyone. Thanks for coming. Thanks for sticking around for the last day of build. Have you guys had a good week? All right. You know, it's always amazing to me to see the amount of planning and preparation that goes into one of these conferences. But I'm especially amazed this week at what the organizers were able to pull off, which is to arrange for a full week of really terrible weather so that you could play with your new toys and get down to coding without any of that guilt about, gee, I really feel like I should probably be outside. But we're actually ending on a good note because I saw Mount Rainier on the way in today, so I think that we chalked that one up as a sunny day in Seattle in November. My name is Sean McKenna. I'm a program manager on the Windows Phone developer platform team. And today we're going to talk about app-to-app communication. If you've been to Andrew Klinick's talk on sort of the overview of the platform, you probably heard what this sort of entails, which is we're going to talk about custom URI associations for applications as well as file type associations. So hopefully you're sitting in the audience wondering, so why are they calling it app-to-app communication? What is this sort of like grandiose marketing term that Microsoft is coming up for a technology that we've had forever? And the answer is, this is actually, we've got a couple of features that we're enabling in Windows Phone 8, but it's part of a broader effort and something that we plan to invest in much further going forward. And so this is sort of an umbrella term that we're using for allowing apps to work with each other. As most of you are probably aware, about 3 years ago, we hit the reset button on the Windows Phone platform. And when we released Windows Phone 7, we had adopted an application model that was really based on isolation, based on sandboxing, as most modern mobile platforms are today. And what sandboxing does is it allows apps to be installed and with no real risk to the user that that app is somehow going to mess up the system, interfere with other apps. The user can uninstall that app if it's doing something malicious or just isn't particularly interesting. And this allows us to maintain one of the really critical and core principles that we have in the platform, which is that the user should never regret installing an app. We want to make it really seamless and frictionless for the user to go grab an app from the store, try it out. If he or she doesn't like it, uninstall it, and your phone is back good as new. But naturally, the flip side of that is that if you don't allow apps to actually work together and share data and complete tasks with each other, that limits a whole bunch of scenarios, as you're probably aware. And so what we're trying to do is maintain that core principle of the user never regretting installing an app, but at the same time sort of thoughtfully and carefully reopen some of those channels of communication so that apps can work together to enable rich and interesting scenarios for end users. So that's kind of why we have this sort of big umbrella term. It is something that we want to invest in going forward. So let's get down to the details here. As I said, the two features that we're talking about today are URI associations, also known as custom protocols or URI schemes, as well as file type associations. So just out of curiosity, how many people have worked with URI associations in Windows or other platforms in the past? OK, a good number of you. So like you say, conceptually, you're going to be pretty familiar with the material I'm talking about today. The two things I really want to get across are how you actually make this happen on Windows Phone, and it's pretty straightforward, and also walk you through some of the user experience aspects of what we've enabled with URI associations and file type associations, because it's a little bit different from the way that these features have worked in the past and the way that they might work on other platforms. So for the maybe 30% of you that didn't raise your hand, URI associations are basically a way for apps to launch other applications to handle particular tasks that those applications may be best able to complete. And on the flip side, for you to register as a handler for a particular task that you're in the best position to complete. So I've listed a couple of examples up here of popular associations that are available in apps on other platforms. Obviously, we can't commit to these being available on Windows Phone on day one, but we expect that they will come into these apps on our platform over time. But actually, what's more interesting is when your app registers as a handler for a particular task using a URI association, we actually expose you through a new set of core experiences. So through the browser, the messaging app, and email. And these are actually three places where we haven't had really good app extensibility in the past. So as part of our sort of overall philosophy of trying to expose your application in the right place at the right time on the phone, we've in the past had extensibility through the hubs and through search, and now we're adding in, frankly, some of the experiences that I spend most of my time in for your app to be able to show up. So file type associations work much the same way. Obviously, if you have a file that your app owns that you want to pass off to the appropriate handler, obvious cases are Microsoft Office documents or PDF files. You can do that. Similarly, you can register as a handler for a particular file type that you're in the best position to render, and you will be exposed, again, through some of these core built-in experiences as a task that can get invoked to handle those files. The interesting additional one here is the Office Hub. Again, not a place that we've had extensibility in the past. And this actually covers more than just files that are saved locally on the phone within the Office Hub. It's actually also an entry point to the user's SkyDrive storage. And so if the user has files stored in SkyDrive that are of a file type that your application can handle, it's a very easy invocation point to jump over into your app. So with that, I'm going to jump into my first demo. And what we're going to show here is actually an enterprise scenario. So as you probably know, Windows Phone is making a pretty large bet on the enterprise in Windows Phone 8. And in fact, there's an enterprise session immediately after this one. And so what do enterprises do if not deal with Microsoft Office documents? So let's go into Visual Studio here. And the app that I'm going to show you is what we call an enterprise hub, or which is basically just an app built using the SDK that an enterprise might release internally as a way to expose news about the company, or about the team, some alerts, information that's useful to the employee, as well as a way to actually install applications. So if you're interested in any of that, definitely come back for the enterprise session this afternoon. They're actually going to walk through building this app. And so when you go to that session, if you do, you have to promise me that you didn't see this app in this session, because I'm kind of stealing their thunder. So we're all good. So as you can see here, I've got a bunch of different panel items. As you cannot see here. There we go. So basically, panorama control that's got alerts and other interesting things. There's Sean Henry. He's actually going to be giving the session this afternoon. So what I want to do here is actually add an additional panorama item where I can list some Office documents that might be interesting to me, and then be able to launch them. So the first thing I'm going to do is insert some XAML to add this new panel item. Oh, got to switch back. Let's drag this over here. There we go. So I've just added a new panorama item that is basically just a list box that's going to show the file name, the last updated date, some simple information about the file. So now I need to go into the code behind for this guy. And I'm going to add just quickly a method that will load up the files. And basically, I'll open up the Solution Explorer here. You can see I've got an Office files directory within my application package. So this is a very simple demo solution where I've got 3 Office documents included in my package. They could just as well be included in my local storage. So I'm going to iterate through that folder, get those files, and then create an Office file view model, which is basically just a container that's going to data bind to the UI, include that information that's relevant. So the file name, the last updated date, time, and that sort of thing. And then I'm going to add that to the list and bind it to my panorama item. I'm going to add the call in my onNavigated to actually load that. And then the last thing I need to do is just add the selection changed event handler for the list box. So this is really where the rubber hits the road. So I get the Office file view model that was selected by the user. and then pull out the storage file instance that's actually representing that file in the package. And so this is a Windows Runtime class storage file you're probably familiar with if you've been playing around with Windows 8 or with our SDK. It's the new Windows Runtime sort of core class for interacting with the file system. And then I'm going to call the launch file async API on the launcher class. And so if you've looked at how Windows is doing URI associations and file type associations, this will look very familiar. It is, in fact, the same code that you're calling on Windows Phone to launch a file to the appropriate handler as you would in Windows. So now if we run this guy again. Whoop. Oh, let me just clean this. Sometimes when you add some XAML, it doesn't pick up the updates. There we go. So now I drag over, and now I've got the 3 documents here. So I can tap on this guy, jump into a Word file. That's now running in Office, in Word. I can open an Excel spreadsheet here. This is actually a read-only copy of the file that Office is getting. The user now has the opportunity, if they want to make edits, to save the file only into the Office hub. So they're not going to be making edits against the file that is available in your app. It's really more of a viewer-type functionality there. But they do have the opportunity to save that file back into the Office hub. So you can think of it as very similar to getting an Office document in an email attachment, opening that in Office. The user obviously can't save it back into the email cache, but they can make edits and save it to the phone. My personal favorite is if I tap on this PowerPoint, actually get this presentation running in the Hyper-V emulator on the phone, and we can actually go through the whole talk here, if anybody's interested in doing that. Maybe not. Let's go back to the full-scale presentation. So that's launching Office documents. The thing I want to talk through now, I mentioned earlier, one of the things that I want to get across in this talk is some of the guiding principles around the user experience and the decisions that we made on how to handle some of these associations. So the first principle that we decided on was that the user should always be in control. So for any of you that lived through the 90s and early 2000s with URI associations and particular file type associations in Windows, I think you will appreciate this principle, which is, back in the day, you'd install a new photo viewer or maybe an experimental browser, and all of a sudden, anywhere that you opened a web page or you opened a photo, that app thought it was the best possible app to handle that particular piece of content. And so all of a sudden, you had no idea how to get back to the previous app that you had installed, which was actually much better at doing what you were trying to do. You're really just playing around with a new app, and all of a sudden, your whole system has changed. And so we want to make sure that the user is always in control of the app that is getting launched to handle a particular task. The second principle is that we actually think of the list of applications and their associated extensions as private user data. And so what we've decided to do is, rather than allowing an app to query which apps are installed and perhaps which extensions are available, we've enabled a full end-to-end experience that's handled by the system. So the classic case is you have a PDF file. You want to know whether the PDF viewer is installed before launching that PDF file. That requires that you know which apps are installed and which extensions are available. Well, what we say is just go ahead and launch that file, and the system will determine if there's no app installed to provide the user the ability to jump into the store and get the appropriate app. And so in that way, we enable the end-to-end scenario that's desired without giving away information that we consider to be private. And the third principle, which is probably the most important one, is that we want to maintain some simplicity and consistency around some of the standard tasks. So as in Windows Phone and Windows Phone 7.5, the built-in applications will continue to handle the standard file types. So we've got a list of those file types in the documentation, but you can imagine things like PNG and JPEG, as well as MP3 and the Office document formats that we just looked at. And so this is somewhat of a controversial decision because it means that apps are not able to take over those extensions. And the reason that we did that is really we want to make sure that for those really straightforward user scenarios, like receiving a photo in an email attachment, that those things are always consistent and predictable. And so while most of us in this room, really the power user crowd, would probably be interested in being able to tweak which default app gets launched and be able to maximize the experience of getting a photo or getting an MP3 file, really the standard user has no interest whatsoever in managing a whole page of settings of default apps and making sure that the right app is launched for a particular case. And so we're very worried about having the situation where my mom gets an email with a photo attachment, and she taps on it, and because she had previously picked some other photo viewer, now that thing gets launched and it's not actually able to show the photo. We want to make sure that those tasks work 100% of the time. So let's walk through the 3 cases that are going to come up as a result of these principles. So the first case is that when an app launches a particular task, in this case it's a URI association, so trying to make a Skype phone call, there's exactly one handler installed. So the Skype app is installed. It has registered as a handler for the Skype URI scheme. And so immediately the Skype app will get installed. The information passed by, in this case, a little real estate app will get passed into the Skype app, and the Skype app can then initiate the call, obviously with user consent. The second case is the one I just mentioned, where there are actually no handlers installed to deal with a particular task. So in this case, I've got a PDF file that represents the floor plan of this exquisite property that is on the market this week only. And the user taps on this, but they don't actually have either the Adobe Reader app installed or the new Windows Reader that we've ported over to the phone. And so in that case, the system will recognize that and actually pop up a piece of system UI, so an action required dialog that says, you don't have an app, you need an app to handle this particular task that you're trying to complete. Do you want to go to the store and get one? And if the user says yes, then we'll launch them into the store, where we've actually indexed all of the registrations that apps have made, and as they've been ingested into the store, to be able to find the appropriate app to handle, in this case, a PDF file. And so from there, the user can choose the app that they want to install and go through the standard store install process. Now, a standard question that comes up in this particular flow is, OK, so after the user installs the app, do we automatically relaunch them with the initial context, in this case, of the file that they tapped on? And this is something that we debated for a while, but ultimately decided that because there's a potentially long period of time between when the user initiates that install action and the app actually getting installed, particularly if the store needs to wait for a Wi-Fi connection for larger apps, that there's a high chance that there's actually going to be a weird situation where the user starts an installation process, goes and checks some email, starts playing a game, and then all of a sudden they're in the PDF viewer. And so we didn't want to enable those types of jarring experiences. And again, this is a case where we've gone for a consistent, predictable experience, even if the user has to do a couple of extra taps. And really all they need to do in this case is back up through the back button to the real estate app, tap on that button again, and they will flow right through. The last scenario is one that we actually think is going to be relatively rare, which is because we're actually taking those standard file types sort of off the table by having the built-in apps continue to handle them, the amount of contention that there will be over other file types and other associations, we expect to be relatively small. But what we're going to do in that case, so in this case, the PDF case is actually probably one where it's most likely to happen because there are a fair number of decent PDF viewers. So in this case, if the user, for some reason, has decided to install multiple PDF apps, they will get a dialog that asks them to choose which app they want to launch to actually handle that file. And this is something that will pop up every time they invoke such a file or such an association. And so we expect what's going to happen is that if, in this case, the user has actually installed multiple apps and they are using PDF quite frequently, that they'll ultimately make the decision, if it's more convenient to just uninstall one of those apps rather than have to make this decision every time. This is really our way of avoiding having a huge laundry list of extensions in the settings app that the user has to manage, because nobody wants that. Well, maybe some people do, but most people don't. All right. So with that, let's jump into another demo. So one of the scenarios that we heard a lot of when people were asking for URI associations was, I want to be able to send a deep link to my app from my backend service. And obviously, we have the push notifications service to do that, but in some cases, apps want to have more of a platform-agnostic way of doing it, and SMS is a popular choice. And so that's something that we wanted to enable. So what I have here is a game, Unite, which, has anybody ever played it? A few people. This is a game that we shipped with Windows Phone 7 in the store as just kind of a sample. It's actually a Silverlight game. And what you need to notice here is that, so I've got all these levels lined up, and I've got all of these little padlocks over the levels beyond level 1, because I actually need to play through the levels in order to earn the right to go to the next level. One of the things that games may be interested in doing in a lot of cases is special promotions, where they say, OK, for one day only, we're actually going to let you play a level that actually you have no business playing because you didn't earn the right to get there. And so you'd like to be able to send a deep link that says, OK, just for today, because it's Halloween, you can jump forward into this level, and for 24 hours, you can play that level. And so this is something that we can do with a URI association. So let's go into the messaging app here. And this is actually a really great way to quickly test URI associations, even on the emulator. You don't actually need to use a phone for this. So I can type in a URI that I might receive from my backend service. And I actually do need to provide a bogus phone number here just to get the send button to light up. But if I send that message, you'll notice that the URI is actually linked. So that's the phone's entity extraction engine is going through, noticing that this is a URI scheme that actually is tied to an app that's installed and registered for such a scheme. And so it's lit that up with a link. And so I can actually now tap on this link and launch directly into the app and into this level that, again, this is level 10. It would take me like weeks and weeks and weeks to get here, but because of this special one-time promotion, I can actually jump straight in. Now, obviously, all the security experts in the room will realize that this is probably not the most secure SMS if you're trying to send this to only your best customers. But obviously, you could put a one-time special use token in here that you actually tie up to your backend and make sure that it's all secure. So now that we've seen what that looks like, let's take a look in Visual Studio at how it actually works. And so there's three things that I need to do to make this light up. The first one is, in my app manifest, I need to register for an extension, which is an extension of type protocol. So if you've done any of the extensibility features, the existing extensibility features in the phone, you'll be familiar with this extensions element. We've added a new type underneath here, which is protocol. And really, the part that's most critical here is the name of the protocol. This is the one that's actually going to determine whether that URI lights up and gets tied to your app. And so that's the one that you saw me type into the SMS. Now, in terms of how that URI that was invoked actually gets passed into your app, it's basically done through our standard extensibility model, which is that we pass in a special URI string that includes an element that has that value in it. So if you've done any work with the search extensibilities or some of the photo extensibility stuff, you'd probably be familiar with this. But we've added a new type of string, which is this /protocol, and then pass in the original URI as a value of one of the query string parameters. So you'll notice this encoded launch URI matches what's here in the nav URI fragment. And that's all basically boilerplate code that you can add directly to your manifest. I will point out that this URI here is actually encoded, so I'm showing you kind of the unencoded version, but when it comes in, it does get encoded. So the next thing I need to do, because you'll notice that this URI here doesn't actually include a XAML page, you need to translate this URI into something that you can actually tie into a XAML page in your app. And you do that using a URI mapper. So I add a Unite URI mapper here, which is actually extending from URI mapper base. And effectively, all this does is take this string that's incoming into the app and pluck out the value of this level to start attribute. And so once it gets that level, it sets it to this existing value here, which is level description to start, returns the XAML page that represents the actual in-game page, and now the app is able to launch correctly into that page, and you can start playing. OK. So we've looked at how you can launch a URI association. We've looked at how you can launch a file type. The next thing we're going to look at is how you can actually handle a file type, so how you can handle a custom file type within your app. And before we look at the code for that, I think it's worthwhile to understand sort of what's happening under the hood, because it's actually going to play into how your app responds to that invocation. And it is a little bit different for file types, because clearly there's a file that has to come across, and it's not something that we're going to pass in a URI string. So if we walk through the example of the real estate app that I showed in the UX walkthroughs, we start from the source app. And the source app is going to call that launch file async method that I showed when launching the Office documents. That launch file async method is a single line of code, and as far as your app is concerned, it immediately launches into the appropriate handler, and the file is gone, and you don't need to care about it. But what's actually happening is that we're going through a file broker, because remember, the two apps are within a sandbox. They don't have the rights to talk to each other's isolated storage, and so that launch API is actually creating a file brokering token through this broker that we call the data sharing service. We're turning that back to the API, which then passes it into the execution manager component. The execution manager component is really the one that just manages which apps are running at any given time. So it passes in the token ID for that brokered file, and then determines, OK, I've got this token. I've got a file that needs to be shared with an app that can handle PDF. Now I need to figure out which apps can handle that. This is where we find out whether there are 0, 1, or multiple handlers installed. In this case, let's assume that there's one. The execution manager then stamps that token with the app ID of the app that is actually going to send the file to, so that only that app can actually access the file. So there's no other, even if another app actually got that token, it wouldn't be able to open it. So now we launch the target app with that token, and you'll see when I step through the code that that token actually does show up in your app, and you use it to call back in to the broker to redeem it for a file. And so this is the kind of the flow of how you're able to pass a file between apps. And so you might be wondering, OK, this is, why do I care, basically? And there are two reasons, really, why I think you should care. The first one is going back to this idea of sort of what is app-to-app communication, and why is this a bigger thing than just file types and URI schemes. And this is an example of how we can maintain the strength of the sandbox. So that these apps are not actually, we're not opening up ACLs and enabling apps to actually go and poke around in each other's storage, but we're enabling the scenario nonetheless. So the file can move back and forth between the two apps without these two apps having to actually be able to fiddle with each other's storage. So that's one. The second reason that's interesting is a little bit more subtle, which is we talked a lot this week about convergence and our path to convergence between Windows and Windows Phone. There's actually another type of convergence that we're trying to drive really hard, which is convergence between the way that our built-in apps work and the platform that they're built on, and the way that our store apps work, which I know is something that a lot of developers have have given us feedback on, how come the performance isn't as good, the controls aren't as rich. And so we're actually trying to drive really hard on that as well. And this is actually a case where the exact same infrastructure and the exact same code paths are being exercised for both the built-in applications as well as store applications. And so in Windows Phone 7, when you got an email attachment with a Word document, say, you launched that Word document and it opened up in Word, the reason that that was able to work was because the Word app actually had a hard-coded ACL to the email's cache, which clearly is not something that we would ever enable for a store app. So in Windows Phone 8, what we've done is now that flow is exactly the same. When the email app gets a Word document, the user taps on it, it goes through this same process to create a token, send that token over to the Word app through the execution manager. The Word app then calls back in to get a file handle for that token, and that's the way that it's able to open it. So we're slowly getting to this point where the store apps and the built-in apps are all working off the same platform, and that's going to be goodness for everyone. So that's under the hood. Let's pop up above the hood again and talk a little bit about file type icons. So clearly, for file types, there are, in a lot of cases, instances where you want to have a different icon, a different asset for representing that file type compared to just your standard application icon. So there's another opportunity for you to expose your brand in the three built-in experiences that I talked about. So the email client, the browser, and Office. So you can provide three different sizes, small, medium, and large. And we recommend the pixel sizes that are listed on screen. Those are actually the ones that we use for the built-in apps for WXGA screen resolution. But they look just fine scaled down to the smaller screen resolutions. So what we said was, let's not bother asking you to provide 9 different icons to handle this, because they're small enough that it's not really worthwhile. So if you provide these different assets, they'll look great on the screen. OK, so now let's walk through the process of actually handling a custom file type in our app. So the scenario here is I'm actually a pretty serious runner. I like to run marathons and get out and run 4 or 5 times a week. And so I'm always seeking out new and interesting routes to run because I don't want to just keep doing the same thing over and over again. And so I have like a little Garmin watch that tracks my progress, and I'm able to upload that stuff to my PC. But with some of the features that we're enabling in Windows Phone, particularly the continuous background execution and being able to track location in the background, I'm actually thinking that a Windows Phone 8 device would be a pretty great replacement for that Garmin watch. And so I'm thinking of building a running app, which is what I'm going to show you, sort of an in-progress version of. So what this app does is, let's actually just run it here so you get a sense. So this app is able to handle GPX files. So GPX is sort of an industry standard for geo-coordinate data. It's used for not only running, but motorcycling and geocaching and a whole bunch of stuff. So it's able to parse those files and take the points and create a line on our new map control to represent those routes. So if I tap on any one of these routes, dive in, it's actually parsing that file, displaying the route on the map control, and then I can start running and track my progress as I go. So this is great, and you can imagine that this app might be tied to some back-end service that itself has a big database of GPX files and routes that I want to get access to. But there's also a whole bunch of content out online for GPX files from sites like Daily Mile and Map My Run, and like I said, for all the other different sort of geo-aware activities, they all have sort of their individual sites that provide those files. So what I'd like to be able to do is integrate all of that great content that is out on the web into my application, so that if I find a great route on a website that has a GPX file associated with it, that I can actually launch my app, get that file, and be able to use that as the route for the day. So let's walk through how I would actually do that. Oops. So it's going to be very similar to what I did for Unite for handling a URI association, but with a few little differences. So again, I'm going to start in the app manifest because I need to register the fact that I want to handle this file type so that the system is aware of that and that the store is aware of that when I ingest the application into the store. And so I'm going to add a little piece to my manifest here. And this is, as you can see, it's a little bit longer than the one that we had for protocol. And that's basically because of the logos that we talked about. So this is where I'm specifying my small, medium, and large assets. These are pointers to files that are in my application package. We recommend that you put them in the assets folder along with some of your tile assets just to keep everything together. But this is really the critical line, which is registering the actual file type that I want to handle. And so you can optionally include a content type here, but really the majority of what the system is driven off of is the file extension. And so the extension that I'm registering is .gpx. You can actually include multiple file type elements here under supported file types. So if you have the sort of canonical example is the Office documents have .xls and .xlsx. And if your app is actually going to handle those two extensions in basically the same way, then you might as well register them here together because there's no use having separate registrations if ultimately you want them to go to the same place. So now I've got that added to my manifest. The next thing I need to do is add a URI mapper to be able to handle the incoming URI. And I should point out here that what this URI is going to look like is something like this. So it's going to be file type association, and then the file token, and then there's going to be a GUID. So the file token is passed in as a GUID. And so you'll notice this file token is associated with the nav URI fragment here. So again, like in the URI association case, I need to take this incoming URI string and map it into something that I can tie to a XAML page so that I can actually render a page. And that is the job of the URI mapper. So I'll add a new class here. And we'll call this run tracker URI mapper. And again, this is going to extend from URI mapper base, which has a single method, which is map URI. Again, like the protocol association case, I'm going to take that incoming URI and map it into something that I can use in a XAML page. So in here, in this case, it's actually quite straightforward. I'm just going to take that file type association file token and replace it with my root page, and then handle the file token actually in the root page. So that sets me up for that. Again, as I mentioned earlier, the incoming URI is actually encoded. So you do need to decode it before you deal with it to remove all the special characters. But now I'm set up that I'm registered for this file type. My app is going to get launched, and it's going to get launched to my rootpage.xaml. So now I need to go into rootpage.xaml and get it ready to actually handle that type. So you'll notice here I've got in my navigation, I'm already handling a file name for something I've already got stored in the application, a root ID, which you can imagine tied to a back-end service. And what I'm going to do is add a new handler for a query string that includes the file token attribute. So pretty straightforward. I'm looking for this file token attribute, and then I'm going to pass it to a new method called process external GPX file. And this is really where I'm now going to interact with that broker that I was talking about. So first I create a subfolder within my local storage to handle all of these roots and store them for further use. then I can get the file name of the file that's actually getting passed into me using this getSharedFileName method, which I'll just tap this down so you can see. So I can call this getSharedFileName and get the incoming file name. And I'm actually going to use that to name the file that I save into my local storage. So the final thing I do is call this copySharedFileAsync method. And this is really where I'm going to take that file that was shared with me and copy it over into my application storage. So the key thing here is you are actually getting a copy. You're not operating on the file that is stored in the original location. And we did that for two reasons. Basically, so that you're not fiddling with the data that might have been shared with you from the other app, and also so that you can actually have that data, make edits to it, and have it live on beyond whatever the other application might be doing with it. So once you call this copySharedFileAsync method, you do actually get the file locally within your storage. And then the last thing I do is actually call an existing method that I've got in the app to take that file, parse it, and set up the root page with the data that I've received. So now I'm handling all that. The last thing I need to do is actually go into my app class and set the root frame to have the URI mapper that I just set up. So the only way that that URI mapping logic that I showed is actually going to get called is by attaching that URI mapper to the root frame. And so I need to just do root frame.URI mapper equals new. And now we should be all set up to actually run this guy. Oop. Oh, nice. But this is not actually the interesting part, because what I want to do is get a file from somewhere outside and launch it. So I've got one saved here from MapMyRun, which is, again, a site that keeps all of this type of information. And so obviously there's a bunch of data here about the run, but I can't do anything with this unless I can get it into the app, because I'm not going to track my location from a website. So along the right nav here is an option to export this route. So I'm going to tap on that, and now I'm going to get a pop-up that says export as GPX. Now I'm going to click on this download GPX file, and I want you to notice, because it might happen pretty quickly, that we're going to go into the IE download page, and it's going to show downloading. And then immediately before the app actually gets launched with the file, you'll notice an icon show up, and that's actually the icon that I've specified as my logo. So assuming this works, you'll see that guy show up, and then should open. Let's try this again. There it goes. And so that's actually taken the file, copied it in, it's parsed out all of the coordinates from the GPX file, and now it's displaying it on the map. So I've got that file that was on the web stored locally within my application storage, and now I can actually continue to use it even if that website goes away. If it gets deleted from the web, I've got it in the app. Again, not rocket science, but something that I think starts to connect the dots and enable connections with some of the interesting built-in experiences. All right. So now we've seen launching a file, launching a URI, handling a custom file. And I think that I saved the best for last, at least in my opinion. This talk is called app-to-app communication, but actually we can use the same techniques and the same technology to enable device-to-device communication. So I'm not sure how many of you got to go to Tim Laverty's talk on networking and proximity. Good number of you, that's good. So he showed a little bit of this, which is handling a URI that's coming from an NFC tag. what I'm going to show is handling a URI that's actually coming from another device. And so the scenario for me here is, again, I'm going to use this Run Tracker app. My wife and I like to go running together. And so I always let her pick the route because, happy wife, happy life. And so she picks the route. But then when we actually go out running, she's actually a pretty big fitness buff, so she'll run ahead of me so that she can do some push-ups while I'm still running up the hill. And then I have to try to catch up to her, which is actually kind of a problem when if she's taking turns really quickly. All of a sudden, I have no idea where she is, and if I don't have a device and I don't have a map, then I have no idea where we're going. And so I would like to be able to have that information as well, so that I know that where she's actually run off to, and I can run after her. And so if I'm carrying my device and want to get the same route that she's using, obviously we could sort of talk to each other and say, okay, what are you doing? And then I go and search for it and do something like I just showed you. But it would be much more efficient if we could actually just tap our devices together, pass that information across, and be off and on our way. So that's the scenario I'm going to talk through now. Just in terms of some details of this, your app can actually, if it's been set up to handle a URI, you can handle a URI that's passed via proximity with no additional code, and actually without even having to take on the proximity capability, because the platform is actually receiving that incoming data and is allowing the user to decide whether to accept it or not. And so from the perspective of your application, you're none the wiser that that's actually coming in through proximity versus coming in from the browser or coming in from another app on the phone. So that makes it really easy to set this stuff up. So let's jump back into Visual Studio here. And what I'm going to do is go into the XAML for my root page. And what I want to add is, I've already got an app bar button down here at the bottom to add the root as a favorite. I want to add another app bar button for share. Call that share. I cheated and put the asset in the folder before the demo, so it's already there. And we'll set up our click event handler. So now I just need to enable sending the URI that represents this particular route via the proximity APIs. So, oh, whoops. Good catch. Seeing if you guys are still awake. It's the last day, I know. Okay, and then here I'm going to do sometimes these code snippets get a little funky with the tabs. OK, so I'm going to get an instance of the proximity device, which basically represents the proximity service on the phone. And then when you use proximity within an application, there's actually no built-in system UI that's going to tell the user what to do. So you need to pop up some kind of UI that says, OK, you've tapped the button. Now go ahead and tap the devices together. So I've created a little pop-up that's literally just a full screen that says, tap your devices together now. And then this is really where the magic happens. So I say publish URI message. I'm passing in. I'd set up the app previously to handle URI scheme because I didn't want to walk through that demo because we'd already seen it. So I've set it up to handle a URI scheme. I'm going to pass in a root ID, which, again, in a real application would probably be tied to some back-end cloud service that would be owning all of those IDs. But in this case, I'm just going to take a hash of a file name because we've got the same file set up on both the devices. And then I'm going to set up a inline delegate handler for when the message is actually sent. So after the message is sent, I want to tear down that UI that I had displayed and stop publishing the message, because otherwise it's going to continue to try to find another device. So that's actually all I need to do from the source app perspective to send the URI via proximity. Now, I do, because in this case the source and the target is the same, I do need to set up the app to include the proximity capability in order to call this API. But otherwise, there's nothing I need to do to enable this. So now let's see if this works. I'm going to switch over to the Wolf. I've got a couple of devices here set up. And I will point out that this is by far the riskiest demo of the session, because we've got 2 pre-release Nokia devices. We've got proximity. We've got network. So there's a lot of things that can go wrong. So kind of, build up your demo karma, and let's see how this goes. So in this app, I'm going to go in and choose a route. If you guys can see that very well. So let's go Redmond to Seattle. Maybe I'll run home today. So I've got the route here. Now you can see I've got the share button. I tap on that. You see my little UI that says tap devices together now. I go and tap them. You'll see on the one on the right, it's saying, do you want to receive this content? So this is where it's passing the URI across. The device on the right is receiving that and is intermediating to make sure, OK, do you actually want to receive this content from this random stranger or not? And if I say accept, then I'll launch into that same route. And now so now I have the route, my wife has the route, she can run off up the hill and do her 50 push-ups, and I can take my time, which is good. And so that just demonstrates how easy it is to enable this stuff. And this is actually kind of a happy accident that we ended up with these 2 features working so well together. The proximity team was setting up to enable this type of sharing of content, and we had all of these other reasons that I've talked about to actually enable URI associations. And so we said, hey, if you pass a URI across, and that's associated with an app, is that app just going to get launched? And we said, well, probably. Let's try it. And there you go. It worked. So I won't tell you that was part of some grand plan from the beginning of Windows Phone 8 planning to enable this scenario. This is kind of one of these serendipitous cases where it all just worked out. So with that, my wife and I are off and on the run, and I suspect that all of you may have to run to another session or to catch a flight. So with that, I will say thank you very much for coming. And make one final point, which is you may have already heard, Andrew Whitechapel and I are working on a Windows Phone 8 development book, which is available just this week for $10 whole. You get the first 6 chapters that we've written in ebook format. And as the additional chapters are released, you will get that updated content without having to pay any more. So it's a pretty good deal. Recommend you go out and grab it. I can take a few questions now, and otherwise I'll be at the booth downstairs afterwards. Where? Oh, yeah. I should have added that to the slide. O'Reilly.com. All right. Thanks, everyone. Thanks for coming to Build.